Okay, so now that we've gone from zeros of the equations to a polynomial in standard form, let's revisit using standard form of a polynomial to find the zeros as they relate to multiplicity and complex zeros. So on A, it says list all possible rational zeros. So it's probably been a minute, but back in Algebra 2, you guys probably talked about looking at the last term and looking at the first term. And I call this P and Q. So we're going to list all the factors of P and all the factors of Q. So factors of P, what multiplies to 20? Well, that would be 1 and 20, 2 and 10, 4 and 5, and that's it, luckily for us. And then Q, what's going to give me 3? Well, my only factors of 3 are 1 and 3, which will help me out in a second. So I'm going to put all my factors of P over all my factors of Q. Alright, so I'm going to have 1 over 1, which is just 1. I'm going to have plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 5 over 1, plus or minus 10 over 1. Those are possible factors. And plus or minus 20 over 1. Alright. So that's all of my factors of P over my factor of Q is 1. Alright, so now I've got to consider, well, what if Q is 3? Well, then I would have all my factors of P, which is 1 over 3, 2 over 3, 4 over 3, 5 over 3, 10 over 3, and 20 over 3. Alright, so that's all of my possible factors. If I were you guys, I would not want to try to figure that out on my own. But it does help us narrow it down to what could they possibly be. So now we're going to grab a graphing calculator and we are going to go ahead and type those in to verify them. So what I'm going to do is I'm going to see, okay, well, I've got a graph that looks kind of like this particular function. Alright, so it looks like I've got a 0 over at -4, I believe. And I've also got this point here that I really don't know yet. So we use our left bound and our right bound type of deal. We go in and we say, hey, find my 0. So then my left bound, I'm going to scroll over to this particular x-intercept. And I'm going to say, okay, my left bound, well, to the left of this particular point, going to the left, is going to be below my x-axis. So my left bound should be right there. And then I'm also going to go and find my right bound after I hit enter, because it's going to prompt you to say your right bound. So going to the right of that point, well, to the right of my x-intercept is above my x-axis. So I should pick a point above my x-axis and hit enter. And then it's going to say guess. And you're going to hit enter again, like we have been. And then it's going to tell us that, hey, this is like 1/3. 0.33333 repeating is just 1/3. Alright, so that narrows it down. So now we can say, okay, I've got x plus 4 as a factor, and then I've got all of this, which is that 3x to the 4th minus x cubed minus 33x squared plus 71x minus 20. And then we can go in and we can use long division. Or we can remember, hey, this is a linear term with just a 1 out in front of the x, so I can use this thing called synthetic division, which is that -4 thing, and then I've just listed my numbers, which is that 3, the -1, the -33, the 71, and the -20. It's basically the same thing, it just takes less time. As long as your factor is linear and only has an x out in front, I can use synthetic division. And since we're going to be using division a couple times, I would recommend it. Alright, so then I just draw a line. Synthetic division works like this. You drop the 3 straight down, and then we just multiply. I'd get -12. 3 times -4 gave me that -12. I'm going to add straight down, which will give me -13. Then I'm going to take -13 times -4, and that'll give me a positive 52. And then add -33 plus 52. That'll give me 15. Then I take 15 times negative 4, which will give me negative 76. Which all in all will give me a negative 5. Negative 5 times negative 4, which will give me positive 20. Adding those straight down, which will give me a remainder of 0, which means since I got this remainder of 0, that yes, x plus 4 was a factor. Okay, so now I only have to look at this polynomial anytime I divide anything else out. So when I go to this 1/3, I can just list these numbers again instead of having to do that fun stuff all over again. Because right now, I've just got x plus 4 times the quantity of now x cubed, x squared, x minus 5. Because each time we divide out an x factor, your degree of your factors remaining decreases. That makes sense. If you're dividing out an x, you should get rid of an x, hypothetically. So let's do that again. So I'm again just going to drop down that 3, multiply 1/3 by 3. I should just get 1, which will give me negative 12 once I add those together. Negative 12 times 1/3 should give me negative 4. Where did I mess up? Uh-oh, this should have been a 19, shouldn't it? Oops. Everything else worked out. I had these numbers pre-written out. I just miswrote. Sometimes I do this ahead of time, just to try to check my work really quick if that needs to happen. Alright, so after I fix that, that should be leaving me with a 15, which works out a lot nicer. And then I got 15 times 1/3, which should give me 5, which all in all should give me 0. Alright, so again, I got a factor of x minus 1/3, and that gave me a remainder of 0. So what I've really got now is x plus 4 times x minus 1/3 times x squared, 3x squared minus 12x plus 15. So now that's as much as we can get as far as real solutions. So part C is a little bit funner, but I'm not quite ready for part C because I haven't found all of my zeros yet. So in order to find the rest of my zeros, yeah, this is going to be ugly if you try to factor that. So you could do the quadratic formula, or you could complete the square. So I'm actually going to go the version of completing the square. So I've got 3x squared minus 12x plus 15 is equal to 0 because that's one of my factors. I can set that equal to 0. So I'm going to factor out a GCF, which is just 3 times x squared minus 4x plus 5, which is equal to 0. And then I'm just going to have to divide off that 3, because 0 divided by 3 is still just 0. Oops, I don't know why that changed that to a 3, because I said 3 probably. Alright, so then completing the square, I'm going to take this 5 and push it over, so I get x squared minus 4x. I leave a space and I say equals negative 5. And then mentally, I'm going to divide that number out in front of my plain old x, which in this case is a 4. I'm going to divide that in half, which should give me 2, and I'm going to square that number, which this time should give me positive 4 again. So, in order to make this a perfect square, I need to add 4 to this side. Well, if I do something to one side, I also have to do it to the other. Yay, addition property of equality. So then, I can rewrite this whole side as a perfect square, hence the name, completing the square. So this is going to be x now minus 2. Quantity squared is equal to negative 1. Alright, so now I can just complete the square and I can say, okay, I've got x minus 2 is equal to the square root of negative 1, which is gross. And so I get x minus 2 is equal to plus or minus I. And then I get x is equal to 2 plus or minus I. Again, it is a lot more conventional to see I coming last, guys. Please remember that. Alright, let's go on to part C. I'm going to have to do that in another video because otherwise YouTube's going to get mad at me.